So up next, our speaker is a really, really wonderful guy. I've seen him present before. It's definitely worth paying attention to every word that he says. Up next, from Telstra, who's responsible for cloud technology strategy, Rick Harris. Please welcome him.
Thanks, Tom. So this presentation is a user story. It's not about building cloud platforms or operating cloud platforms. It's not a marketing or salesy pitch, but I will talk a little bit about products, but enough to set the scene. So hopefully that's okay. We are in the non-technology track, but there is a little bit of code in some of the slides. Actually, it's more like config files, so I guess that's okay. So the initiative I'm talking about is a program that we call internally Symphony. And that refers to an intelligent network orchestrator that is designed to deliver multiple products, a stream of products to allow us to build new products more quickly. So hence the focus of the talk there, using OpenStack to deliver products more quickly to market. So Symphony is this platform that we're building using OpenStack as a base to help us bring these new products to market more quickly. So the kinds of products that we're talking about, the first one is one that we call Internet VPN. That is allows customers to connect from their branch offices into to each other via IPsec tunnels, and then through a virtual firewall to the internet, and optionally connect phones and laptops and things like that in through SSL VPN into that WAN as well. So it's like a WAN product for smaller deployments. The second product is our Cloud Gateway product, and that allows customers who have an MPLS network with Telstra to connect that MPLS network through a virtual firewall to the internet or to cloud providers, whether that's AWS or Azure or OpenStack. The third product is a data center interconnect product. It doesn't use any virtual network functions at all. That's to create like an Ethernet point-to-point connection between two data centers around the world. So we'll configure a couple of dozen data centers, and customers will be able to say, I want to connect to that data center in Tokyo, to that data center in Sydney, and have a point-to-point Ethernet service created on demand between those items. So the objectives of the Symphony program are shown up here. The first one there, unified product experience. This is intended to provide one place for customers to browse, buy, configure, manage, support and operate their products. The next one, we've got faster to activate. We want customers to be able to self-serve and have these products activate almost immediately. We want it to be faster for Telstra to develop new products. So from the time a new technology appears on the market to the time that we can get it into our customers' hands, we want that to be brought shorter and shorter and shorter. Ultimately, we want it faster for customers to be able to get value out of the services that we sell to them. And the last one is the platform for innovation. So this is to enable our customers, system integrators, partners, to deliver their own products on top of Telstra's core assets. So we want to take all those assets that we have buried away inside the Telstra network and expose those to our customers and partners for them to build their own products on top of those. So Symphony takes Telstra's infrastructure along the bottom there, all these different components of the infrastructure that exist out there in our network and in our customer sites. It provides a mechanism to chain those services together into multi-component service constructs. So I want to connect this network to a cloud, for example. Bring them together in a seamless way to then provide that dynamic on-demand kind of experience. So I want this set of services chained together in this way, and press the button and you want to see that happen immediately. And then once we've got that, we've got the ability to tweak the attributes of those services, so scale bandwidth up and down, or deploy a temporary service or a trial service for a short period of time, and then tear it down when the trial's over. Or rebuilding a service chain in its entirety if we find that some component of the network has failed. So it's like a self-healing kind of a capability. So that's the product and what we're trying to achieve. Now I'm going to spend a little bit of time talking about the architecture that we've built using OpenStack and how this is relevant to OpenStack. So this is a high-level sort of stylised overview of how the network works to deliver these sorts of products. So over on the left, we've got the black components here, which are the customer's network. So an MPLS network connected to various different sites for the customer. And that is connected to a gateway, that orange box, the Next IP gateway, and that's a way of connecting an MPLS network into the OpenStack cloud platform. That then connects to a number of tenants within the OpenStack platform. Now, I should say at this point, the OpenStack platform that we're using is Cisco's Intercloud Services platform, which is their OpenStack public cloud that they have deployed into Telstra's data centres and integrated with Telstra's networks. So Telstra doesn't actually build or operate this OpenStack platform. We're effectively using a public cloud platform as a customer ourselves. So we've got broadly the same access that a customer of Telstra who's buying OpenStack would have to deploy services. So the first tenant that's been created there is the virtual network function tenant, and that's the one up the top there, the dynamic networks tenant. And so if that happens to have, say, a virtual firewall in there, then the traffic can come from the customer sites through the gateway, through the virtual firewall, and out through to the internet after having been secured appropriately. The next important tenant, and this is a completely independent tenant from the VNF one, is the second use that we're making of OpenStack. We're actually running the application itself inside OpenStack as well as the virtual network functions. So by the application, I mean the orchestration platform that delivers the services outcomes, the automation and the portal and all of those sorts of things. And that's sitting in this application project. And there's a management traffic that passes between them, so the application manages the configuration of the virtual network functions inside the VNF project. And this is all sitting inside that public cloud platform, so it's alongside and coexistent with all of our other customers who are using this same cloud platform. The application tenant also needs to communicate with a variety of Telstra core systems for billing, for customer databases, etc. And that is also a separate network connection into that project. So now I'm going to have a look at how each of these tenants is actually configured inside them. So if you were an OpenStack user, what the configuration of each of these looks like. And this is, as I said at the start, sort of highly stylised, so it's not precisely right, but it gives you an idea of how we've used OpenStack in order to deliver this kind of a product. So the first tenant that I'll look at is the application tenant. So this is where our application sits. So in the middle there, we've got a Cloud Foundry cluster. This is where most of the components, the business logic and the application sit as services that are deployed into the Cloud Foundry platform. On the left, we've got the internet connectivity so that the customers can come in and connect to the portal. On the right at the top, we've got the management network connecting off to the billing and customer databases and all of those sorts of things. And down the bottom, we've got two components there, NSO, which is Cisco's Network Services Orchestrator, which is what Cisco have renamed the acquisition TailF to be. And that's the core of the orchestration and configuration of the VNFs. That is connected through yet another neutron router through to the VNF management network, and that's how NSO manages the configuration of the virtual network functions. And the other component there, ESC, is the Elastic Services Controller, is another component of Cisco's architecture, which is the part that actually talks to OpenStack to instantiate new VNFs. So that's the application tenant, and that is self-contained there. In the VNF tenant, so this is one of the places where we put virtual network functions. So there'll be a number of these throughout the platform. This one shows three different customers, the yellow customer, the green customer, and the purple customer. The first one, customer one there, has two virtual network functions. They happen to be a web content filter and a firewall. Goes through the next IP gateway to the customer's MPLS VPN. Customer 2 just has a firewall, also goes through a next IP gateway to the customer's VPN. The purple one doesn't have a connection to a customer's VPN. It's accessed via the internet only, but it's got a router, a firewall, and a web content filter. That's equivalent kind of configuration for the IPsec tunnel concentration use case that we were talking about before. On the bottom left, we have the connectivity off to the NSO that does the management and configuration of all of these devices. And I'll talk about how the devices get created and managed in a sec here. So this is the orchestration. It's divided into two parts, the data plane and the control plane. So I'll start with the data plane, the green part. So this is where data flows in the network. So from various customer sites over the customer's MPLS VPN through the next IP gateway into some combination of virtual network functions and then off to the internet. And this is an example because each of the products I talked about before could end up with quite different configurations, which is, of course, one of the advantages of using a flexible underlying infrastructure. The control plane is then the thing that creates all of these things and configures them. So a customer will come in up the top left, connect to the portal, say, I want to order a particular service. That goes off to the VMS application. So VMS is the name of the application that Cisco have built with us to do all of this orchestration. That VMS application calls NSO and says, please go and instantiate one service type X, and NSO will then connect to one of our back-end services, the network orchestrator, to say to the MPLS network, this customer has asked for this service, please connect the MPLS network to the next IP gateway. We'll talk to the next IP gateway saying, please connect this to the cloud. It will talk to ESC to say, please create 3 VNFs for me. And so this uses the public OpenStack APIs to go there and create those VNFs. And once they're created, NSO will then go and connect to each of those VNFs to load the configuration that the customer has asked for. And then the service is up and running. So, stepping out of the technical bit for a little while, what are the benefits that we had of using OpenStack for this underlying platform for delivering this service? The first and one of the more obvious ones is speed. We were able to get our trial prototype environments up within days in a company like Telstra, with the procedures and so on that we've put in place over the years, that would have taken a much, much longer time to get in place. We were able to, partway through the program, when we realised that there was a need for yet another testing environment to test a particular problem, or that we had a different group that needed to run a set of tests that was going to happen at the same time, we were able to create new test environments. The whole thing, the Cloud Foundry and all of that has an automated deployment, so we could just create a new tenant, deploy Cloud Foundry, deploy the networks, have the application up and running in a day or two. The flexibility, we were able to change the construct. So I showed you an example of how the networks are connected within these tenants, but we experimented with that before we got to where we are today, and we will probably continue to experiment with that. Using OpenStack means that we don't have to have had it all locked into a design that's going to be managed and deployed by hand into a physical environment. We have the ability to create new VNF environments or to expand the VNF environments based on demand very easily. Innovation, that was one of the key objectives of this program, was to enable other people to innovate, but it also allowed us to innovate with the platform as well. So we have a new product idea, it gives us the opportunity to try those products, and if we don't like them, abandon them, or we haven't lost anything. Our ability to create sandboxes to quickly and easily experiment with or demonstrate the capabilities of the products, or experiment with alternatives of the products, was also really important through the development of the platform. Connectivity, now this one's kind of specific to our circumstances. The cloud we chose, the Cisco cloud, is very well connected with our MPLS network, so we were able to take advantage of that. But also the ability to have granular access lists and routing and so on deployed at the same time that the virtual network functions are deployed was also very helpful, and we could keep the orchestration and complexity of the deployment down. We've got close to full automation of the deployment of the application. There's a few config type tweaks that get done, but essentially we're able to deploy a new copy of the application pretty much hands off, including creation of all the VMs, creation of the virtual networks, and all of those things. It also gives us the opportunity for doing full test automation. So the ability to run up the environment and then automate testing of individual products, to have it actually go and create a product and then create test harnesses to test that product sends the data through properly, and then tear it all down again as part of our release process, is something that we've not been able to do within the company before. Some challenges. Because we chose the most convenient available platform, we are limited to where that particular platform is physically located. The fact that we're using a public cloud platform and not one that we purpose-built does mean that we're somewhat limited to the changes that we can make. And I say mostly there because we work very closely with Cisco, and they did actually enhance the cloud platform, the OpenStack platform, in a few cases to help make this a success. We also found that the neutron networking did not do everything that we needed. We had a mixture of neutron networking and VNF-based networking to meet all of the different types of needs that we had. So normally now we run about 6 to 8 environments concurrently for various different stages of the testing, for production, for DR, etc., plus the development environments that we use to set things up. We found that automation tools are still somewhat immature. We looked at a variety of them. We found that most of the focus that these tools are putting in is how to deploy OpenStack. So we didn't want to deploy OpenStack, we already had OpenStack. We wanted to use OpenStack. And really the only one of these configuration management tools that allowed us to effectively create and destroy and configure virtual machines using the OpenStack APIs was Ansible, and even then it was only the 2.0 beta version at the time, it's now been released, that could do that. However, we still had some issues, we still have some issues. Just one little example is if you deploy a server onto an OpenStack platform and you have two network interfaces that you configure, it does that fine. However, if you want to assign a floating IP address, it won't know which interface to assign that floating IP address to. So sometimes it'll do it on the right interface, sometimes it won't. And there is actually no way of specifying which interface to put in place. So still some work to be done in this case. Another slight challenge is we created lots of networks and we continue to create lots of networks. It's a good thing we don't have to use the Horizon console to manage these things. They're all pretty well managed through the orchestration, and so we don't really ever have to go into this view. It's kind of useless. But it also meant there are too many routes and too many ACLs to manage manually, and so we had to code the automation of those. And this is even for the application environment, where it's a relatively fixed environment, but there's still quite a lot of different networks and configurations, and we need to make sure that the security is locked down properly. We also found that providing OpenStack CLI access to everyone was a bit tricky, so we ended up packaging that up into Docker with all of the dependencies and so on, so that was something that was helpful for us. And lastly, where we're going next, we want to have more and more different types of VNFs, so we need to qualify those VNFs onto the OpenStack platform, integration with more types of networks, etc. We do want to do that extension of the automated testing from simple unit-based testing to doing full end-to-end product deployment and test the throughput of the products that we deploy. We will use other environments to host our VNFs, so not just the CIS cloud, but it is certainly still going to be OpenStack and probably spread around the globe. And I think there's, as I said before, there's opportunity to improve the Ansible OpenStack modules. I suspect we'll focus on that rather than the others because Ansible's the one that's made the most progress. And so that's all I have today. Do we have any time left for any questions?
So here's what we'll do. First, let's everyone thank Rick Harris. And now you have a decision point. If you are rushing downstairs for the next presentation in the basement, you may start rushing. If you're not doing that, let's ask Rick some questions. Who'd like to begin? I'm going to run a microphone to you.
This may be an obvious question. Did you try Heat? Was that available to you?
We did try Heat, but again, we did find some difficulty with the configurations that we were trying to use. We were mostly using this for testing environments. I think it would be worth retrying Heat because we tried a very early version of Heat. So yeah, it's a good point. We should have another look at Heat.
Thanks.
Excellent. So, as I dodge people here, are there any further questions for Rick? Over here.
For the deployment, if OpenStack deployment itself, from based on your experience, if there is a new release, so how do you upgrade it?
Well, because we are using OpenStack provided to us as a service, we get the notification from Cisco that they're doing an update just so that we're aware of it, and then the update happens and we don't see anything more than that. So as I said, this is a user story, so none of that behind the scenes stuff is visible to us as consumers. There are certainly other people in Telstra who have those challenges, but luckily in this case I was not one of them.
Maybe time for two more questions for Rick. Is anyone interested in jumping in? I'm being pointed over here.
What was the main decision for going with for software as a service? Was there like a major decision?
Going with which as a software as a service? OpenStack?
Yeah.
We had already made the decision and already had the OpenStack platform in place before this project started. So the decision was really more about how do we get this project delivering results as quickly as possible. And so because this cloud is here, we could use it as customers. It was actually pretty much a no-brainer, partly because we wanted this project to be a software project. And whenever you bring physical things into a project, at least in Telstra, that tends to add a lot of lead times to your project times. So our biggest objective was to get value as quickly as possible, and there was very little reason to go and try and build something ourselves.
Brilliant. And so the final question for Rick Harris here from Simon Anderson.
Hi, Rick. In terms of the VNFs that you see coming down the pipe that are in demand, are they, for Telstra specifically, are they custom VNFs that are really specific to the telecoms use case, or are you looking at, broader-based VNFs like, load balancing and you've already pointed out firewall and those kind of VNFs that are more broadly applicable?
Yeah, so there are actually a handful of NFV type projects happening in Telstra at the moment. This one is more focused on building products for customers, and so the VNFs are ones that are logical in that situation. So yes, firewalls, content filters, global load balancers, there's a variety of those sorts of ones which are based on services that customers would buy. However, there are other parts of Telstra who are working on virtualising our mobile core, virtualising our media platforms, etc. So I think you can generally safely assume in a company the size and complexity of Telstra, we're seeing the full spectrum of possibilities.
Fantastic. Let's everyone thank Rick Harris again.
Thank you very much.